with that then.
That's a good one.
I hate probability, but whatever. It's actually what I wrote my thesis paper on in grad school. It was more probability stuff, but I just don't really like it. It's not. I like algebra. I like algebra type stuff. I'm more into that. Even trig. I love trig. Trig's some fun stuff. All right, but probability, we can do it. It's no big deal. A monkey crossbred. A monk. Sorry, not a monkey. A monk. How did I see monk? You know what I saw?
It's funnier if you say monkey.
It is. I saw monk and bread, so I was thinking monkey bread. That's why I said that. Okay. Anyway, back to the problem. A monk crossbred plants, which can have purple or white flowers, and obtained 648 plants with white flowers and 222 plants with purple flowers. Okay. Find the experimental probability that a plant had each type of flower. I gotta read that again. Can have purple or white flowers. Monk, which can have purple. Okay. So there's an intersection here, I'm assuming. Right? And the total number in here was 648 that had white flowers. And 222 that had purple flowers. They didn't tell us how many plants.
Well, I assume you just add them together.
A monkey crossbred plants, which can have purple or white flowers and obtain. So, okay, so I'm just misunderstanding the question. That's not what we have. It's either white flowers or purple flowers, not white and purple flowers.
Yeah.
That's what I don't understand. I guess I don't get how flowers
work. I think it's just
work.
one or the other.
Okay. All right, sounds good. This isn't that hard then. Yeah, so 648 plus 222 is 870.
That sounds about right.
870. So that's the total of plants. What's the probability the plant had white flowers? Well, the white ones were 648 out of 870. So you just divide that in your calculator. 648 divided by 870. And that gives you approximately, because we're rounding it, the probability is always a number between 0 and 1. So it's 0.74 is the probability rounded. And so the other one would just be, do you know what the other one would be?
You'd
Without
have to
using
divide 222 by 870.
You actually don't even have to divide it. You know that they have to add up to 1.
Oh, so it would be point two. Yeah, that.
Good job. And just to show you that that's true, punch that in, and voila. If you round it, you'll get 0.26.
That's pretty nifty.
Probability is always, the entire probability always adds up to 1, which is 100%.
I didn't know that, and that would have been a useful thing for my teacher to tell me.
Yeah, 100, everything, probabilities of the entire universe adds to 1 because it's 100% probable. So like when you're flipping a coin, it's either heads or tails, but it's a 100% that you're going to get one or the other. It's a 100% chance. So that's 1. 100% is 1, a probability of 1.
Yeah.
Make sense? A marble is selected at random from a jar containing 10 red, 70 yellow, 20 green. From theoretical probability, find the theoretical that it is either red or green. So the total, what you're going to do is put the total at the bottom. The total number of marbles is at the bottom. total outcomes. And the
And then you
top
put the desired outcome at the top.
You got it. Desired outcome. And how many ways are there to get the desired outcome?
30.
There's red or green. Yep, 30.
Yeah, so it'd be 10 and 20, which is 30. Yeah.
So type an integer. So it could be 3/10, or you can write 0.3. Right?
Mm-hmm.
Making sense there?
Yep.
Next page. A pet store has 14 poopies, including 5 poodles, 5 terriers, 4 retrievers. If Rebecca selects one puppy at random, the pet store replaces the puppy with a puppy of the same breed. Ah, get it? Then Aaron chooses a puppy at random. Find the probability that they both select a poodle. So what's the chances that the way you do this is called the I don't remember. Is it called the multiplication principle? Probability?
That's not, what do we call it? I don't even remember.
I can't remember what it's called, but you basically multiply the two probabilities together.
Yeah.
So what's the probability that Rebecca selects a poodle? 5 out of
14.
14. Multiply that by the probability that Aaron selects a poodle. And remember, they replaced the poodle.
Mm-hmm.
So his is also 5 poodles out of 14.
Yeah.
So multiply those together. 5 squared basically divided by 14 squared. And it's 1 round to 3 decimal places. 0.128 is the probability.
Mm-hmm.
Okay, makes sense how we did that?
Yes.
Moving along. A and B are independent events. Find the probability of A and B. Independent
You
events.
just multiply them?
Do you have the formula? There's a formula for this, if they're independent or if they're dependent. I believe you do. I believe you do just multiply them.
Yeah, I don't have my notes with me in my backpack downstairs.
Yeah, I believe the probability of A and B, if they're independent, is just you multiply them because it's the what is that principle called? Of probability. It's not called the multiplication principle. I just don't remember what it's called.
Yeah, I don't either.
Probability principles. See if I can find it. Yeah, it's not. I don't see it in there. It's on the tip of my tongue. It's on the tip of my tongue. But yeah, this one is just multiply them together.
Mm-hmm.
Because they are independent. Because if they were not independent, you would have to find the probability of A given B first, and you'd have to subtract.
Mm-hmm.
Probability of A and B both happening is the probability of A times the probability of B given A, which, because they're independent, the probability of B given A is just the probability of B. It doesn't change at all.
Yeah.
Okay.
Mm-hmm.
All right, you got some more? Is that all the stuff you had for this?
Yeah, let me pull up my math schedule and see what we're gonna learn next.
Is it called the counting principle?
That does not sound familiar.
Yeah, I don't think it is. I feel like it might be called the multiplication rule.
Yeah, I don't really remember. Let's see. Tomorrow we learn mutually exclusive events.
Good stuff. Fun stuff. Mutually exclusive means that it's different than independent.
Mm-hmm.
Let me see if I can. Do you have like work that you can do?
Oh wait, hold on. Wait, I found my notes from today. The little equations. No, they're covered. What the heck? It's like a smartboard thing, but like you know how you can like do the reveal thing?
Yeah.
The reveal things are over the equations.
No.
No. Why would you do that? That's the only thing I need. Oh man.
It's okay. We'll talk about mutually exclusive. When two events are
I can give you my notes. Wait, hold on.
So mutually exclusive means that they can't both happen at the same time.
Yes.
So if they're mutually exclusive, I'm going to go to the next page. Mutually exclusive means that if let's say A and B are mutually exclusive, that means that the probability of A and B, both of them happening, is 0. That can't happen.
Yeah.
And also the probability of A or B happening is equal to the probability of A happening plus the probability of B happening, because they're mutually exclusive.
Mm-hmm. Here, wait, I can put some things on the Jamboard here.
And by the way, the notation you're going to learn is and. You use this symbol right here.
Yes.
Intersection. And for or, you use union. So just be aware of that. You might see it written in those ways instead.
Oh yeah, wait. Here are these. I got them.
You found them?
Yes.
Yeah, nice. There you go.
Here's an example one.
So if the events are not mutually exclusive, then yeah, you see how you don't have to worry about this, because this is just equal to 0. If they're mutually exclusive, this is always equal to 0. But if they're not mutually exclusive, then you have to subtract out their intersection, basically. So the probability of either of them happening, you have to take the probability of the one happening plus the probability of the other, but then subtract out their intersection because you counted it twice.
Yeah.
Does that make sense?
Mm-hmm.
So do you have a problem we can do?
Yeah, on page 6.
Dang, you were so quick, girl. You are dealt one card from a 52 card deck. Find the probability that you are dealt a 2 or a 3. A 2 or a 3. Are these mutually exclusive? Yes or no?
Yes.
They are. These are mutually, because you can't get them both at the same time.
Okay.
And so what's the probability of being dealt a 2 or a 3? Well, the probability of a 2 or 3 is going to be equal to the probability of 2 plus the probability of getting a 3. And what's the probability of getting a 2 in a 52 card deck?
I have no idea.
Well, how many 2s are in a standard deck of cards?
I have no idea.
Oh, okay. Well, here's what a standard deck of cards
Why
is.
would I know that?
Let me teach you poker. 2,
Okay.
3, 4, all the way to 10,
Mm-hmm.
and then Jack, Queen, King, Ace.
Okay.
And that's for spades. Spades is the black suit. Looks like a shovel,
Okay.
kind of. Okay. And that's also for clubs, which is like clovers.
Mm-hmm.
And that's also a black suit. And that's also for hearts, which is red.
Mm-hmm.
And that's also for diamonds, which is red. So there's 2 red suits and 2 black suits. Kind of have to know that.
Okay.
So you've got a 2, 3, 4, all the way to 10, Jack, Queen, King, Ace for both of these. 2, 3 to Ace, and then the black is 2, 3 to Ace. So there's 13 times 4. Got it?
Mm-hmm.
Which is 52. So there's a 13 total, plus 13 total, plus 13 total, plus 13 total. Your total is 52. Okay?
Mm-hmm.
That's a standard 52 card deck. So now can you answer the question? What's the probability you're going to be dealt a 2?
2 is 4 out of 52.
Right? Or 1 out of 13.
Ah.
Right?
And 3 is also 1 out of 13.
That's right. So what's the probability you'll be dealt
2,
a 2 or
13.
2 out of 13. So now this one is harder. You are dealt a 7 or a red card. So these are not mutually exclusive. I'm going to say ME for mutually exclusive. They're not me.
Yeah, why?
Because you could get a 7 that's a red card that's a 7.
Okay.
And you don't want to count that twice. So
Yeah.
how do you do this? Well, it's 7 or red. So that's the probability of getting a 7 plus the probability of getting a red minus the probability of getting a 7 and a red. That's
Okay.
the formula. So what's the chance I'm going to get a 7?
4 or 1 out of 13.
Good. What's the chance I'm going to get a red?
26 out of 52.
How about 1/2?
That is 1/2.
Because
Oh,
the
yeah,
half are red and half
oh
are
my
black.
God.
Yeah, it's okay. You don't play poker, so you wouldn't know that. And what's
No,
the
I don't.
probability I'll get a 7 and a red?
2, 13?
Not 2 out of 13.
No, 2 out of 26.
Isn't it 2 out of 52?
Yeah.
Yeah, it's 2 out of 52. Or you could say 1 out of 26.
Okay. I knew it
Right?
would have something to do with the 26, I think.
Yeah, yeah. Remember, we're just reducing those. You could have said 4 out of 52, but that reduces, right? 4 out of 52, but that reduces. You could have said, like you did, 26 out of 50 or 2. Yeah, 26 out of 52, right? But
Yeah.
that just reduces to 1/2.
Yeah.
Okay. So your answer is this. And so we have to get common denominators. What's the common denominator?
26.
Good. So that equals 2 out of 26 plus 13 out of 26 minus 1 out of 26. And that equals 14 out of 26. right? Which can reduce further to 7 out of 13.
Okay.
So what you did not want to do is you did not want to count the red 7. When you didn't want to count it when you're counting the 7s and the reds, because then you would have counted these 2 twice. So that's why we had to subtract that out. We didn't want to count it 2 times.
I see.
Because they're not mutually exclusive.
Mm-hmm.
They could both happen at the same time. All right, how about a red 7 or a black 8? Are these mutually exclusive?
Yes.
Yes. You can't get a red. You can't get, yeah. Red 7 or black 8 are definitely mutually exclusive. Those can't both happen at the same time. When you flip a card, it can't be both a red 7 and a black 8 at the same time.
I see.
So what's the probability of a red 7 or a black 8? It's just equal to the probability of that red 7 or the probability the probability of the black 8.
Mm-hmm.
And how many red 7s are there?
2.
2 out of how many?
26.
52?
Oh, 52. 52.
Yeah, because the whole deck, there's 2 in the entire deck. And how many of the black 8s are there?
Also 252.
There's 2 in the entire deck. So in total, so you could reduce that now, right? That's 1 out of 26 plus 1 out of 26. And what do you get when you add those?
2.
2 out of 26. And that reduces to 1 out of 13. Whoa.
Yeah, I was like, wait a minute. 2 out of 26 is very small.
Okay, get it?
Mm-hmm.
So that is probability. I know, it's pretty awesome.
It is.
It's pretty awesome. Okay.
All right. That's all I got.
All right, sounds good.
Cool.
Peace out.
By the way.
Yeah.
By the way, got an 81 on my math test.
Hey.
Friday, I'm going up.
That's
slowly.
good, right?